Thanks.
Sure. I'll just restart it. Example 2. In 2001, the mean rate of inmates on death row was 40.7 years, according to data by the U.S. Department of Justice. A sociologist wondered if the mean age has decreased since then. She randomly selects 32 inmates who have a mean age of 38.9 and a standard deviation of 9.6. Tests the claim at the alpha equals 0.05 level of significance. So we're looking at
A mean.
the mean age. So it's a mean. The mean was 40.7, but her claim is the mean is now less than 40.7. And alpha will be 0.05. The sample mean was, she had 32 inmates, so that's the size, with a mean of 38.9 and a standard deviation of 9.6. Now, the reason I set it up this way is so that once you've done those three things, you don't have to go back to the question and read it again. You just have to fill out, if it's a mean, then this needs to be all about the mean, and then you fill out the mean side. So we're going to use StatCrunch, and in this case, the t-stat, because it's about the mean. So we'll do stat, t-stat, one sample with summary. Our sample mean was 38.9 years. My sample standard deviation was 9.6 years. My sample size was 32. We're doing a hypothesis that the mean is equal to 40.7 and the mean less than 40.7, a left-tailed test. Okay, so that matches exactly what I have in that paper. So that also makes that easier for you. So my answer was, I had a sample mean of 38.9, a t-stat of minus 1.06, and a p-value of 0.1485. So our test statistic is t equals negative 1.06, and our p-value is p equals 0.1485. So two things here. P is big, but also notice your t statistic is -1. And if you remember z-scores, it was 1 standard deviation, 2 standard deviation till you got to a small amount. So -1 is pretty close to the mean. Okay, so just something to think about. So our p-value is greater than alpha, and we do not reject the null hypothesis. So we go to this statement, and we can say there is not sufficient evidence to make a conclusion or to support the claim that the mean age on death row is less than 40.7 years. Any questions? So again, 40.7 and 38.9 are just too close together to get the evidence. Another way that 38.9 would be better is if she had a bigger sample. Because remember, when you have a bigger sample, then you're going to get a skinnier distribution. Which means you're going to have a smaller percentage or a smaller little tail here. So this will be a smaller p-value. But up here with just 32, it's a much bigger p-value. You see that?
And to determine if P is greater than or equal to A,
Alpha,
alpha,
you start with the alpha that's given. Alpha is always given to you. So in this case, if you look up in step 2, it was 0.05.
0.05, okay.
Yep.
Oh, okay, I see, yep.
It's either 0.01, 0.05, sometimes 0.10.
Okay,
Depends on the question.
thank you.
You're welcome. All right. Next one.